So if we go back to, if we have 3 prices, so we'll now do our example with calls. So what we're going to do is just repeat this call function, and I'll make it a little more convex to make my demonstration a little clearer. So let's say we have this very convex call function, and we have 3 strikes. The notion of convexity, as I just described, means that if I connect the function at k1 and k3 with a straight line, that the function on that interval is always below, or more formally, not above the straight line. So here's the value c of k2. And the relationship that we saw a moment ago, that c of k2 is less than or equal to a weighted average. I'll write it as t of c of k1 plus 1 minus t c of k2, k3. Convexity says that if we look at any point k2 in between k1 and k3, its value, which is here, is below the weighted average of the 2 values, c of k1 and c of k3. And the reason is, this right-hand linear combination is on the straight line. So convexity says that if no matter where k2 is, its value is below the value on the straight line. Now what's t? Well, we can see t parametrizes k2 from k1 to k3, namely that when t is 0, I get, so this corresponds to t equals 0, and this corresponds to t equal 1 in the way I've parameterized things. Right? So we start, so going from, so the coefficient t is this portion of the curve. So t would be k3 minus k2 over k3 minus k1. And then the coefficient of C3, which is 1 minus that, would be this proportionate part of the curve, which is K2 minus K1 over K3 minus K1. So the notion that the value at an interim point is less than a linear combination of prices at the extremes is really a reflection of this graph. And this equation can be algebraically reformatted to tell you an equation in slopes. And again, we could see that the equation in slope talked about the slope between these 2 points. See if I have another blank slide. I do not. The slope between these 2 points and the slope between these 2 points. What can we see is happening? That as the interval is moving to the right, the slope is increasing. So the notion of convexity, which we can think of as the shape, namely the curve lies below segments joining points on it, can be interpreted 2 ways. One is we can interpret it in the context of that the slope is increasing on each interval as the interval moves to the right, or we can interpret it in the context of the value of the function at any interim point on an interval is less than a combination. And these were exactly what we saw on the previous slides. So let's just go back to the call. So these are the two statements that we were just looking at graphically. One is a statement of slopes, namely that the slope on the left interval is smaller, no bigger, than the slope on the right interval. The other statement, which is algebraically equivalent, tells you that the price at any interim point has to be less than this linear combination of prices. The same analysis can be done with put prices as a function of strike, because put prices are again convex. We saw that on this graph, namely that they both have the property that if you connect any 2 points with a straight line, the curve lies below that straight line. So they both have the same convexity attribute, and that means that we can express that in terms of slope relationships or in terms of intermediate value properties. Now on this slide, with puts, we have a typo. This should be less than or equal to. In other words, what we're saying is that the slope increases as the interval moves to the right. It's the call where the slope decreases. Again, let's look at the visual. You can see that the slope of this call function increases as you move to the right because it goes from very negative to less negative. If you look at the slope on the put function, you can see that the slope increases as you move to the right. So that's what this says. It says that the slope on any interval to the right will exceed the slope over an interval to the left. That's because the slope is increasing. And then we can algebraically restate that in terms of we have the same intermediate value property that a put price is less than or equal to the weighted average of the put prices at the ends of the interval, because again that gives you the value on the line. So the visual is exactly the same. You have a put price. Here's the put price at the intermediate value. Here's the linear combination of endpoint values. So it's exactly the same visual we saw here, but done with a put rather than a call. And then we do a little bit of algebra.